All right, let's check this out. Exercise 11B. Number one, that is a parallelogram. The area for a parallelogram is base times height. In this case, the perpendicular height is 8 inches. The side that it's perpendicular to is 20, so that's 20 times 8 gets us 160 inches squared. And number 13, in order to find the perimeter, we need to find that missing side. We got two sides, got to find the third. That's all about the Pythagorean theorem. We get 17 for x, add all those guys up, we get 40. The area of that triangle is going to be 1/2 times base times height. We're looking for the right angle, and of course there it is. Our altitude is built into that right triangle. The base and the height are 18 and 5, or 8, I'm sorry, 8, wow, 15 and 8, or 8 and 15. The order does not matter. 1/2 times 15 times 8 is 60 units squared. The legs of the right triangle end up being the base and the height. Number 3, we got a funky little shape here, don't we? I broke it up this way here at first. I'll do it another way here in a second. This top triangle here is easy. I got those two dimensions, 1 and 2. The bottom, I said triangle. Gosh, I am loopy right now apparently. 2 and 9 are the sides of that rectangle. We've got to do a little bit of figuring to get that the length of this purple side that I put in here. If this is 4 and, well, that's 9. That's 4, that's 1, so this has to be 4. So 1 plus 4 plus 4 is 9 to match up on that rectangle down there. That ends up being the puzzle piece we need to figure out now that the area of each of those are 1 by 2, 2 by 8, 2 by 4, and a 2 by 9. Here, I'll break it up differently here this time. Here it is. Whoops. My bad. The wrong little button here. I'm getting there. Here it is not broken up. And yeah, it doesn't really matter how you see it and break it up. I just made a bigger rectangle kind of there in the middle. That piece is going to be 4. And then, yeah, it's actually just find the area of all those little pieces and add them together. That's how that works. On number 4, this is a parallelogram. Hold on. Sorry, yeah, so the sum of all of those pieces when we multiply them together is 44 units squared. Number 4, this is a parallelogram. That's my perpendicular base. I'm sorry, there's my perpendicular height. My base for that is 11 square root 3. The 9 square root 3 is do jack squat with. Multiply those across. The numbers on the outside multiply. The numbers on the inside do. The square root of 3 times the square root of 3 is 3. So 88 times 3 is 264 units squared. Number 5, this is a rhombus. I know it's a rhombus because all the sides are the same. Therefore, we got these perpendicular sides out in the middle. I have diagonal information given. That first diagonal has a length of 12. 6 plus 6 is 12. Now I'm going to use the right triangle that happens from the angle there in the middle. 6 squared plus 8 squared equals 10 squared. So that other piece is 8, which means the other diagonal is 16. Those diagonals get chopped in half. So now 1/2 times 12 times 16 is 96 units squared. Number 18, this is an isosceles triangle, recognized by the two legs that are congruent. So I need the altitude, which is going to come from that opposite vertex to the opposing side, making a right angle. That 10 is the base, which now gets split in half. So 5 squared then plus h squared equals 13 squared. H is 12. So therefore, we get to do the 1/2 times 10 times 12 gets us 60 units squared. Number 7, the perimeter of that rectangle is 100 with one side equal 20, which means the opposite side is also equal to 20. 100 take away 40 is 60. Those other two sides have to add up to equal 60, so they're 30 and 30. So the area is going to be 20 times 30, 600 millimeters squared. Number 8, the perimeter of a square is 30 inches. Therefore, each of the sides, 30 divided by 4, all the sides are the same, that's at 7.5. 7.5 squared is 56.5 inches squared. The area of a squared, if that's 100 feet squared, then the side will be 10 squared. That's 10 times 10 is 100, so each side is 100, so therefore 4 of those sides, 4 tens, it gets us 40. If the area of a circle is 9 pi centimeters squared, That 9 is the radius squared. Area is the radius squared times pi. So the radius is 3. The circumference is double the radius times pi. So 2 times 3 is 6. 6 pi is 6 centimeters is the circumference. To go the other way around, if the circumference is 12 pi millimeters squared, that 12 is double the radius, so the radius is 6. Area is the radius squared times pi. That gives us 36 millimeters squared. Number 12, the sides of a triangle are 10, 10, and 12. That means it's going to look like number 6 up there. It's isosceles. 12 is my base. I need that 12 gets split in half to get 6 and 6. 6 squared plus 8 squared is 10 squared. So that's 1/2 times 12 is my base. 8 is my height. It gets me 48 units squared. If the diagonals of rhombus are 10 and 8, then this area is 1/2 times 8 times 10. Easy peasy. Trapezoids. Okay, the area up here is 1/2 times B1 plus B2 times the height. On number 14, the height is given to us as 5. It's the perpendicular connector of the two parallel sides. Those two parallel sides are 11.6 and 6.4. Those are my bases. Plug them into the formula. Boom. Number 15, I see my bases. Those are 10 and 30. We need to go calculate the height. It's isosceles here because of those 45-degree angles. It's also 45, 45, 90, which is going to be handy. So that 10 comes down here to 10. That 30 has 2 other parts, so those also have to be 10. Because it's a 45, 45, 90 triangle, this is a leg, so is H. So look at there, that's 10. The height is 10. 1/2 times 10 plus 30, those are my bases, times the height 10, gets us 1/2 times 40 times 10, 200 units squared. Trapezoid area. The perpendicular connector, that's 16. My parallel sides are 16 and 10. Those are my bases. 1/2 times 10 plus 16 times 16 gets us the area. On number 17, the bases are 10 and 26. We are missing the height. It's not isosceles, but that height will chop off a, look at there, 30, 60, 90 triangle. 12 is the hypotenuse. My height is the short leg. So 12 divided by 2 is 6. There's my height. 1/2 times 10 plus 26 times the height 6 is where that comes from. Number 18, the trapezoid area. 6 and 16 are set for us. And those are my base. 10 is my height. Look at there. They're connected with that right angle. So I'm set up for the area, no problem. Now, how to figure out what 10 is? Whenever we see those two right triangles, we can always, or two right angles, we can always turn it into a rectangle and a right triangle. That ends up, the 10 comes over to the right, 10 and 10, and then this is a 45, 45, 90 triangle. 10 times the square root of 2 is what x is equal to. All right, the sides of an isosceles trapezoid are 5, 5, 10, and 16. Therefore, it's going to look like this. Its area is what? Well, 10 is B1, 16 is B2. Doesn't matter the order of that. Every time we have an isosceles trapezoid, we make a rectangle in the middle, 2 congruent right triangles on the right. So because of the rectangle, this 10 drops down and becomes a 10. 16 minus 10 leaves us 6. Therefore, the 3 and 3 are there. From there, we get that the height is equal to 4. And now we're good to go with our area formula. 1/2 times 10 plus 16 times 4. Area is 52 units squared. Now, to figure out what the angle here is, this little extra credit question, it will be, because of this right triangle, I can use sine, cosine, or tangent to figure it out. If my h here is, that's the opposite, my height is opposite x in my right triangle. 5 is the hypotenuse, so I chose sine. Sine of x equals 4 over 5, and then we can solve for sine that way. The other angle is going to be supplementary to it. A little bit extra bonus, kind of cool on those isosceles trapezoids. We can do that. All right, number 20. 30, 60, 90 review. Short leg, long leg, hypotenuse. Given is the long leg. Long leg to short leg, divide by square root 3. Square root 15 divided by square root 3 is a square root 5. Both those numbers are inside the square root. And then short leg to hypotenuse times 2. Square root 5 times 2 is 2 square root 5. Number 21, right triangle with two sides and an angle is what this is about. That's going to be sine, cosine, tangent. This case, it's opposite and hypotenuse. Sine. The sine of angle F equals 15 over 22. So therefore, the arc sine of 15 over 22 gets us that angle. Number 22, the angle is given. The adjacent side is my variable. The hypotenuse is 23. Cosine of 23 is a over 23. Put that over 1 and cross multiply. 23 times cosine of 25 gets me my answer. Number 23, we know two sides. We need to find the third. That's the Pythagorean theorem is where this comes in. 2 square root 11 squared plus 2 square root 5 squared equals c squared. 2 squared is 4, square root 11 squared is 11. 2 squared is 4, square root 5 squared is 5, so that gets us 45 plus 20 is 64 equals c squared. The square root of 64 is 8. So there you have it. Let me know what questions you have. Thanks, bye.